Next, in the same exercise number 1.2, in the second question is like this. Find the HCF and LCM of following pair of integers and verify that LCM into HCF equal to product of two numbers. In this first question, 26 and 91. So first step, 26 equal to, and then next 91 equal to. So let us find out the prime factorization. 2, here it is 13, here it is 13, 1. So 2 into 13. Then 91. 91 can write as it, here it is 7, 1, 7, 3, 13, then 13, then 1. So we can write here as 7 into 13. Okay, so let us find out first. Let me find HCF. HCF means what? Common factors. Only want to consider common primes in that least power. So here common only 13, 2, 7 no common. So 13 power here 1, here also 1. So 13 is the common factor which is having the least as 31 itself. So 1 time 13 want to write. Then no other common factors, so leave it. That is the HCF. Then LCM. LCM equal to, want to consider, you should consider all primes and it's the highest power also want to consider. Here only the number 2 here, first prime 2, then no other number here, so that is the highest power is 1, so 2 raised to 1 or 2. Then into the next 13 you can consider, so 13 here also 1, here also 1, the highest power is 13 itself. 13 raised to 1 itself, then into the next 7, only 1 7 here, that is the highest. So 2 into 13, 26 into 7, which is equal to 182, that is the LCM. Then we have to verify the relationship. So first step, we can multiply that LCM into HCF or HCF into LCM, 13 into 182. That answer is 2366, 2366. Then we can go for product. Okay, product of the given two numbers or product of two numbers. That is a given two numbers now. So 26 into 91. That is also when you are doing this multiplication, you get the same answer, 2366. So both answers same. So hence we verified. Hence verified. This is the way we want to find the finding the HCF and LCM and verify the relationship between that two LCM, HCF as well as product. Okay. Then we directly I am going to the next question. Two more questions here in the same Roman letter that you can do as a homework. Now we can move to the third Roman letter in that first question. And here the question is like this. Find the LCM and HCF for following following numbers. Okay, following integers by applying the prime factorization method or that fundamental theorem of arithmetic. And that's the one question I am doing here. It is 8, 9 and 25. Same method, 8, 9 and 25. First step, we have to do the prime factorization of these all numbers. So 2, then 4, here it is 2, then 2, then 2, 1. So 8 equal to 2 cube. Then next 9, 3 we can take, then 3, then 3, 1. So 9 we can write it as 3 square. Then 25, 5, 1. So 25 we can write it as 5 square. Then now asked to find both LCM as well as HCF. So HCF. HCF means a common number. Is there any common factor here now? 2 cube, 3 square, 5 square. No common factor showing here now. So which is a number which is a common factor for all numbers. Okay. Every number has a particular one factor. Okay. That factor is 1. Number 1. Okay. You can write here into 1, into 1, into 1. So all numbers are having the 1 as a common factor. So if there is no other common factor, means then 1 is only the one common factor. So HCF equal to 1. Then LCM. LCM 2. First you have to consider 2. The number 2, that is prime number 2. In that the highest power is 2 cube. No other power. So 2 cube we want to write. Then 3 square. 3. The next consider 3. And in that highest power is 3 square. So 3 square. Then next you consider 5. In that 5 square is the highest power. So answer is 8 into 9 into 25. Which is equal to 1800. So this is the answer of HCF as well as LCM. So So LCM equal to 1800. So this is the answer. This is 2, 3 numbers means you are not able to get that relationship between that LCM, HCF and product of that only satisfied for 2 numbers. Okay, not for 3 numbers. Then we can move to the next question.